Okay, so today we're going to go over magnetic field line quiz. Bring that up for you real quick. All right. So today we're going to go over magnetic field lines quiz. Like I said, we are going to look at this right here. Looking at number 1. You should have gotten the answer solenoid. Number 2, electromagnet. Number 3, galvanometer. Number 4, electric motor. Number 5, domain. All right, so now let's talk about what does magnetic flux mean in terms of both magnetic fields and magnetic strength. Okay, the magnetic flux is going to be whenever you have a magnet, just like this, okay, you have a perpendicular line here. Lines are going to fly through that perpendicular line, okay? That means that is the flux. How many of those lines are going through that specific point or plane that is perpendicular? The strength is determined also by how many lines are coming out. So that makes the strength of a magnetic field proportional to the magnetic flux. So you have magnetic flux is how many lines are going through a plane that is perpendicular, and then it is proportional to the strength. All right. And it's also concentrated right here at the poles. Remember that it's concentrated here and not as far as concentrated out this region. It's concentrated right here at the poles. Magnetic flux. Okay, next one says, what are the 3 ways that we can increase magnetic flux around an electric magnet? Okay, so that's where you had your setup where you wrap the nail with wire. The more loops you have, the stronger the magnetic field. If you put that rod in there, then you're going to increase that magnetic field going around those coils. And if you apply more batteries or more volts, that's what you saw in your lab. So on number 7, you should have had increased current, put an iron rod through, or more loops. Number 8, we want to know, describe the direction and shape of the magnetic field line of a bar magnet. Okay, if you didn't use this terminology, I counted it wrong. If you did not say that it leaves the north magnet and loops around and goes into the south, or you didn't draw that, I may have counted it half off if you drew it, but you didn't show me arrows, which way it goes, because I don't know that you know which way it goes. So it leaves the north, loops around, and comes into the south. Okay, so that should be what you put on that one. Number 9, where is the north pole of the Earth magnet? Okay, so we're talking about the magnetic field. And remember, magnetic field and geographic are different. So some of us put at the top, which would be incorrect because that's the magnetic south pole, the geographic north. So you should have put on that one geographic south pole or the bottom of the Earth. Either way, I would have counted those answers right. Number 10 says, where is the Earth's magnet's field strength and the field the strongest? And we have at the poles. So number 10 should be at the poles. What happens when if a magnet is dropped? So if I drop this magnet or I strike it with a hammer, you scatter the field lines or the domain lines inside this magnet so it loses its magnetism. That's how you can cause a magnet to lose its magnetism. So that was number 11. Number 12, how could you magnetize a non-magnetized steel bar? If you bring a permanent magnet and you rub it on a non-magnetized steel bar, this is actually aluminum, but if you had a steel bar and you were rubbing it this way, you could make it magnetized. So rubbing it, if you said brought it near it, I went ahead and gave you credit for that. But on number 11, it was rubbing it or stroking it with a permanent magnet. That was number 12. Number 13. What is the difference between a temporary magnet and a permanent magnet? The main difference is when you bring a magnet near a temporary magnet, it's going to be magnetized. Okay, but then at that point, when you take it away, it'll lose its magnetism very quickly. Permanent magnets are going to stay that way for a long period of time, and it takes a while for them to lose their magnetism or magnetic properties. So that should be something you wrote down. If you wrote down that it was harder to magnetize a permanent and easier to magnetize a temporary, that is accurate. I would give you some credit for that as well. So that was number 13. Number 14. In the right hand holding a rod with the current through it, in the right hand holding a rod with current going through it, the thumb points in the direction of the current. So the thumb's always going to point in the direction of the current in that case, and the fingers would be the magnetic field. So you have a magnetic field current going this way, the magnetic field would be going following the fingers. So you should have put current first and magnetic field after that. If you didn't do that, if you swapped them, you lost credit, because it should have been thumb is current, and then the fingers is the direction of the magnetic field. All right, thanks.